So for this question, you've been asked to see if this piecewise function is differentiable at x equals 1. And so first we have to see if we're continuous. So we'll look at the limit as x approaches 1 from the negative side. Well, that's the upper function because this was x less than or equal to 1. So we'll show 1 over 2x, which is equal to negative 1 over 2. Positive 1 over 2, excuse me. And now we'll look at the same thing from the right. Limit x approaches 1 plus. Now we're using the function 3 over 2 minus the square root of x. Well, this is 3 halves minus 1, which is also 1 half. And so the limit as x approaches 1 is equal to 1 half because both the left and right limits equal a half. But we also need to check the function. What is f of 1? And we know it's 1 half, but we have to write it to show that we know the full limit definition. And then we can say, therefore, we are continuous at x equals 1. So that's essentially the first half of the problem. Now, to show that we're differentiable, we also have to find the derivative of 1 on the minus side. Is that equal to the derivative of 1 on the right side or the plus side? But we've talked about using the limit definition to show these derivatives. So we're going to write that the limit as x approaches 1 from the minus side of 1 over 2x minus f of x, because this is where we're going to plug that 1 in. And if you wanted, you could have written this instead as minus 1 over 2 minus 2 to the 1 minus. But because we're going to plug in for x, we should just show what you see here. And in the denominator, we will write x minus 1 on the negative side. Or we could say, another way to write this is, hey, 1 is the number, 1 minus x, and when we plug in for 1 minus, we're going to get 0 in the numerator and 0 in the denominator. This is just another way to write the derivative at 1 minus. And so now we'll take the derivative. Well, this is equal to the derivative with respect to x of 1 half x to the negative 1, which is equal to negative 1 over 2. And now we will subtract 1 from this exponent, and it will become x squared in the denominator. And now we'll do all the same stuff on the right-hand side. So we'll say the limit x approaches 1 on the positive side and now we do everything the same, except we use the other function, 3 over 2 minus the square root of x minus f of x all over 1 minus this x. So now we're taking the derivative with respect to x of 3 over 2 minus x to the 1 half. And that's equal to, well, the first term is 0 because the derivative of a constant is 0, minus 1 half x to the negative 1 half or square root of x. And so now we'll plug into both of these. When we plug in a 1 here, we get negative 1 half. And when we plug a 1 in here, we also get negative 1 half. And so we can see, since the derivatives on left and right are both equal to 1 half, and we were continuous, we can say, therefore, we are differentiable at x equals 1. And so the way I graded this is if you showed this limit statement. I don't love the way that does that, so we're going to undo that. If you showed this derivative statement, you got half credit. If you showed the actual limit definitions here and here, then you got full credit for that portion of the problem. This was worth 5 points. The way I graded it was this portion here. Get that out of there. This portion here was worth 1 point. Showing that we were continuous and that we checked our functions was worth 1 point. Each of these derivatives was worth a point. So if you got this, that was worth a point. If you got this, that was worth a point. And showing the limit definition was worth a point.